introduction to functions today. So before I tell you what a function is, we got to talk about what a relation is. And so a relation is literally just a set of ordered pairs. And ordered pairs are literally like points on a graph. So like x comma y. If you want to look down to the example underneath, I've just got a list of points there. So a relation is just a set of ordered pairs. It doesn't have any special requirements or anything like that. So just a set of points. It can also be a connected graph, like a line or a parabola or something like that. Or it can just be individual points. We're going to kind of look at both of those today. Now, does anybody remember maybe from first semester if I asked you to find the domain of something, what we're going to be looking for? What do you think of when you see the word domain? Like if you had a graph. Yeah.
How far it goes horizontally.
Oh, that good. Okay. So if you have a graph, especially if you're doing like interval notation, I would go from left to right. You're describing what's going on. Does it go with X or Y? X or Y? Okay, I about had a heart attack, yes. Okay, so this is X values for your domain. If they just list points, you're actually going to list the X values. If we have a connected graph, like a line or a parabola or something like that, then we're actually going to do some interval notation. Okay, now range. If you're doing a graph, what you want to do any kind of interval notation, you want to come from the bottom of the graph to the top, so down to up. And we'll get into that in a second. But if you just have a list of points, you're just going to write down the Y values. And we're going to do X values and Y values in our first example. So I literally just have a list of points. So I know you guys can plot points, so we're just going to do that really quick on the graph here that's provided. So I have a relation, just means it's a set of ordered pairs. So we're just going to plot, they've got 5 points here. So first number is your X value, second number is your Y value. So just see if you can put these points I've got listed here on the graph real quick. Should have 5 different points. And once you plot them, don't be tempted to play connect the dots or anything like that. Just leave them as 5 separate points. If you have a relation in this format and it asks you for the domain and range, this is not connected, so you don't do an interval. What you do is you literally just list for the domain the X values of the points, and then for the range the Y values of the points. Now, if any of them repeat, you just list it one time, and they don't have to come in a particular order. So you don't have to do least to greatest or greatest to least or anything like that. And literally what I usually just do is I just write them as they appear in the problem. So I'm just going to write down my X coordinates here. So I've got 0, -2, -3, -4, and I'm writing too big, 5. So just literally a list of the X values, and then the range, if you just have a set of points, is going to be a list of the Y values. And again, they don't have to come in a particular order. I usually just write them how they appear in the problem. So I'm just listing these Y values. They're all different. If any of them repeat, you only list it one time when you write down the domain or range. Okay, now to be specific a little bit more with what a function is. A function is a relation, so a set of ordered pairs, where every X value has only one Y value. I'm just going to say relation where every X has only one Y. The main thing that I would have written down here to remember that, I would write no X value repeats. You can't have an X coordinate with 2 different Y coordinates or 3 different Y coordinates. Each X has to only have one Y value that goes with it. And to relate for that is what I have underneath there, which is the vertical line test. Sometimes people call this the pencil test. Does anybody remember this from Algebra 1? Like, what is, just raise your hand and tell me if you remember. What is the vertical line test, or what is it looking for, or how do you use it? Do anybody remember anything about vertical line test? Like I said, some teachers call it the pencil test. Yeah. Exactly, perfect. Okay, so vertical line test, this is a test to determine if you have a function. All right, and then to perform the test, like I said, sometimes people will call it a pencil test. I just will slide my pen or pencil across the graph. Any vertical line can only touch one point. So any vertical line only touches one point, and that's going to mean, if that's the case, it passes the vertical line test, and then you will have a function. If you can draw a vertical line on your graph or look at your pen as a vertical line or pencil or whatever, and you touch more than one point, then you are not a function. Okay, so let's look at the one we just graphed. So if I slide my pencil across here or draw a bunch of vertical lines, is this relation that we graphed right here going to represent a function? We're good here. You would only ever touch one point. I know it doesn't ask you this, but I'm just going to write this in here real quick. So that first graph that we did, that is a function. Now, forgive me, the second graph I have here, I don't know if you guys can see this, it's really small. There are actually points that are on this graph. I'm just going to kind of highlight them with my marker here real quick, because they're really tiny. I need to make those bigger, but there are points on that graph. So the question is literally just yes or no, and you can use the vertical line test to check this out. Again, don't go back and play connect the dots. These are just individual points. Would this relation, yes or no, be a function? No. Okay, if you notice, and you don't have to draw this in, this would be a no to answer that question. This right here, if I drew a vertical line, would touch 2 points. So any vertical line, if it touches more than 1 point, it's not a function. So I'm going to write no, this one's not a function. Fails the vertical line test. Just because it's not a function, though, doesn't mean you can't write down the domain and range. Now, I don't have a list of points here, so we're going to have to look at the graph. And again, it doesn't matter the order you put them in, but if I just have points on a graph, I usually just go from left to right to make sure I cover my domain. So my first point that I touch would be right here, and I'm just going to write down that the x-coordinate's -4. The next point you touch is 0, 2, so the x-coordinate there would be 0 for my domain. And if I keep going across here, I have a point with the x-coordinate of 2. I have a point here, let's see, this is 3, 4, so x-coordinate's 3. Now, these last 2 points, they both have the same x-coordinate of 5, but you don't write that twice. You just write it once when you're representing a domain. If it's a repeated x value, but you don't have to write it twice. When you write that out, you just write it once. And then I just do the same thing for the range, but I just go from the bottom to the top to make sure I cover everything. So these 2 points both have the same y-coordinates, -4. If I keep going up, this y-coordinate, this point's -4, 0, so the y-coordinate there is going to be 0. This point has a y-coordinate of 2. And then these two guys here have the same y-coordinate, that's 4. Again, if it's repeated, you just write it one time. You don't list it twice. So that's if we just have points on a graph. Is anybody having a question so far? Yeah. No, it doesn't matter. No, the reason I did it that way there is because that's how I read the graph. But yeah, they don't have to come in any particular order as long as you list them all. All right. Wonderful question. Now, let me scooch this up. So now these graphs at the bottom are a little different because they're not just points, they are connected graphs. So we're just going to do the vertical line test real quick, just yes or no. What do you guys think? This parabola, would the parabola here, would that be a function? Oh my goodness, it's so quiet. Yes or no function? Would it pass the vertical line test? If you made like a little table, would any of the x values repeat? No, you're good. Okay, any parabola, it doesn't matter, turn up or turn down, this is going to be a function. So don't worry about any parabola, that would be the case for. Okay, now, if you're going to do domain and range here, we would not want to list points, right? That would be super annoying because we'd have to list an infinite number of points because it's all connected. So when you do the domain and range for a graph that's connected and not individual points, we want to use that interval notation. So what would you tell me, just raise your hand, see if you can remember, what would you tell me from left to right for your domain? What would you write for this parabola that I have here? For the domain? Yes, okay. And then 2 for the price of 1, it gave me the range too. Now the domain goes left and right forever, so you would cover the entire x-axis, and that will cover any parabola should have that same domain. It goes left and right forever, whether it turns up or turns down. When you do the range, that's your y values. You want to come from the bottom of the graph. That points down forever, so I start that interval with negative infinity, and then you do stop at this point here, which is the vertex. The highest y value you touch is 5. There's nothing above that, and so that's why that has a bracket on it, because you actually touch that point. Okay, what do you guys think for the one in the middle? So I've got a circle here. Function, yes or no? No way. This would like fail the vertical line test in a bunch of different spots all the way across there. Now, just because it's not a function doesn't mean we can't write the domain and range. Can anybody, this is tricky. I don't know if we've done anything like this year. Can anybody tell me what the domain would be for that circle? Perfect. Okay, so if you start, like if you're sliding your pencil left to right, that's how I do domain. The first point you touch would be right there at the -4, and you actually touch the point, so you want to use a bracket there. Now, this whole time I'm going here, I'm covering all these x values, right? But I stop touching the circle when I get here, and then there's nothing more that goes to the right side of that. So it's just -4 to 4. Both of those would have brackets because you have actual points that you're touching there. What would you guys write for the range? Same thing, right? If it's centered at 0, 0, which it is, we'll do some different stuff later in the semester, but it's actually exactly the same for the domain and range if you have a circle centered at 0, 0. All right, now the last one is just a line, right? Would the line be a function? Would it pass the vertical line test? For sure, right? I'm only touching one point as I slide across there. What would you write down for your domain? Left and right. For sure. Any line, you're going to go like this points to the left forever, this points to the right forever. You're going to cover the whole span of x values. What about the range there? Same thing. This goes down forever, this goes up forever. That's actually true for any line that you have, -infinity to infinity. I'm sorry, this is shaking all over the place today. Is anybody having a question? Okay. Now, this last example real quick, and then we're going to evaluate some functions. This is called a mapping diagram, and this is just kind of another way to describe the domain and range. So this is not a graph, but it's kind of a little bit of a visual thing here. So a mapping diagram will have like 2 boxes. What you want, and you don't have to write this, but I'm going to write it on my paper. On the box that you have on the left, you want to put domain values, and on the box you have on the right, you're going to put the range values. This is very similar to what we listed on the front. If we just have a set of points, I don't have a parabola or a line here. Again, like the front, if you have a value that appears more than once in the domain or range, you don't write it twice. So I have just my x values I'm going to put in this box, and you don't have to put them from least to greatest or anything like that, just in any order. So I'm just going to write them as they appear. So I have an x coordinate of 2, that repeats, so I don't write it again. Then I have an x coordinate of -3, and I have an x coordinate of -4. So I'm just representing each of the different x coordinates. Then you're going to go through there and you're going to write down for the range the different y coordinates that you have, and they're all different for this question. You have 3, 5, 7, and 9. Okay, does anybody know how to actually do like a mapping diagram? Like what you do? I don't know if you guys would have seen this in Algebra 1 or not. Do you know how to map on the mapping diagram? Okay, I promise it's super easy. All right, so literally all you're going to do, you're going to draw an arrow. It has to come from the x value to the y value that it goes with. So for example, that first point they listed was 2, 3. You just literally draw an arrow and it comes out of the x value and points to the corresponding y value. So 2, 3, that's trying to tell me that point. The next point, they have 2, 5. So I would have another arrow from the 2, but the next arrow would point at 5. -3 would be an arrow pointed at 7, and -4 would be pointing at the 9. So it maps the x value to the y value. Just literally arrows come out of the x and point to the y. Now, does anybody know, can you tell, is this a function? Why not? Yes, okay. If your x value repeats, which I do have here, you have 2 arrows coming out of the same number, so this is not going to be a function. That x value of 2 repeats. If we actually put it on a graph, it would fail the vertical line test there. Okay, let me try one more with you. So just remember, you put the domain on the left side and the range on the right side. So all these x values, I've got 1, 2, 3, 4. Now for my y values, I have 3 in both of the first 2 points, and then I have 5 in the second 2 points. To do the mapping part, you just draw an arrow from the x value to the corresponding y value. So 1 goes to 3, 2 also goes to 3, 3 goes to 5, and 4 also goes to 5. Now, yes or no on this one, is this a function? Yes, it's okay for the y values to repeat as long as each x value has a different arrow coming out of it, not 2 like this one did. This is a function. If you put this on a graph, it would totally pass the vertical line test. Okay, is anybody having a question about domain, range, and writing that stuff down? Okay, now I'm going to kind of just separate this. The rest of this that we're going to talk about today is just real quick how to evaluate a function. Might want a calculator for this. I think most of it you can do without, probably just in your head a little bit, but you're free to use the calculator if you need to. So most of the problem with this for people is just going to be the notation is a little weird. So what this is going to say in my blank here, it's going to say a function rule. So function rule is what's going to go in the blank right there. It's an equation that represents an output value in terms of an input value, which we'll do here in a second. And you can write a function rule in what we call function notation. Okay, now what I have underneath is just an example of probably what you guys are used to seeing in terms of a function rule, and they can be written in both of these formats, but what you're going to see mostly as we go through the functions unit is the function notation. So these two, they're literally identical to each other. This is read the f parentheses x. They read that as f of x or a function of x, and that is just interchangeable if you guys were to see with a y. So f of x is just notation. F is not a variable. It's just saying it's a function of x, so it would pass the vertical line test if we put this together. And so those are interchangeable with each other. To evaluate a function, just remember f is not a variable. You are literally just going to plug in, like what they're doing here. They're evaluating the function with 1 plugged in for x. So I would say f of 1. Everywhere you see an x, you just replace it with the 1, which is what they did. They just took this and just did 3 times 1 plus 2. And I should have had this simplified here, but f of 1 would be equal to 3 times 1 is 3 plus 2. This is 5. The actual answer to that question then would be 5, but just to let you guys know what it means, on a graph, that means my x value was 1 and my y value was 5. So that's what it means. That f is not a variable, it's just notation. Okay, so we're just going to evaluate here in a second, but to define these real quick, the independent is going to be this blank. Independent variable, which is usually an x. It might be a different letter depending on how the problem is written, but it's going to be what's on the right side of the equation in the format that we've got for function notation. It's going to be the input value. So you're going to plug something in for x. And then the dependent variable is y, or especially if it's written in the function notation, f of x is how you guys are going to see it in most of these questions. That is just the output, is not a variable. It's the output of the function. And it says it's called dependent because it depends on what you plug in for x. If I plug in 5, I'm going to get a different number than if I plug in 10 or something like that in my function rule. So let me scooch this up. I promise this is not hard, just the notation is weird for people. So don't forget f is not a variable. All right, so here's my function rule. It says we're going to find f of -4, f of 0, and f of 8. And then they give me the function rule here. F of x is 3x minus 5. Now, what that means is we're going to have three different problems here. We're going to plug in the x value that they're giving you in the parentheses. So, function evaluated at -4 is what this means. Everywhere you see an x in the function rule, you just put a -4. And then you grab your calculator or you do this in your head. You're just going to simplify the right side only of that expression. This would be -12 minus 5, which is going to be -17. So that is my actual answer. So f of -4, the function evaluated at -4 is -17. That's the answer. If you want to think about this in terms of a graph, it would mean if I had the x value of -4, the y value would be -17. That would be the point on the graph. The actual answer to the question is just the output value though. So if I do f of 0, literally function evaluated at 0, all I got to do, everywhere I see an x, we're just going to put in a 0. Okay, now don't put 3 because I did that this morning, embarrassing. Anything times 0 is 0, so this is 0 minus 5, and so -5 would be my answer. And again, you don't have to write this, but that would correspond on a graph to the point I plugged in 0 as my input value. My output was the -5, so that would be the point 0, -5 on a graph. And I just got one more real quick, and then we'll do a little bit more complicated stuff at the bottom. So f of 8, function evaluated at 8, just means everywhere you see an x, just replace it with the number 8. This would be 3 times 8 minus 5. This would be 24 minus 5, which is 19. You guys don't have to write out a bunch of work for this. I'm just trying to show you where my answer is coming from. My answer would be 19. That would correspond to 819 as a point on the graph. Is anybody having a question? Okay, now, at the very bottom, if you have multiple function rules in the same problem, which I do here for the last example, they will use different variables. So, for example, this says f of x equals x plus 2. And then the one next to it just uses a different letter, so it's g of x. That's just to say we have a different function within the same problem, so I'm just using a different letter. And then the last one says h of x, so this is 3 different function rules here. So you just want to make sure that you use the correct function rule to evaluate the problem. So when I do these, easiest thing I can tell you to do is figure out each of which one you need and then plug it back in. So for example, this one says h of 2 minus g of 3 plus 2 times f of 4. It's kind of like 3 problems in one. So I got to figure out what h of 2 is. So just make sure, go up to the directions and grab the function rule that goes with the h. So that's 3x plus 6. Everywhere you see an x, we're just going to plug in 2. And so 3 times 2 would be 6 plus 6, that would be 12. Then I need g of 3. And you could do these in any order, it doesn't matter. But just make sure you plug it into the correct function rule. So g of x is -10x minus 4. So if I want g of 3, I'm going to do -10 times 3 minus 4. So that's going to be, what, -30 minus 4, which is -34. And then I also need f of 4. Now, there's a 2 in front of it, but don't worry about that just for a second. I need f of 4. So the function f evaluated with a 4 in it. That one's the first one that's listed there, just x plus 2. So I plug in 4 for x. So it'd just be 4 plus 2, which is 6. Once, I'm not on the screen, forgive me. All right, let's scooch that up so we can see it. Okay, now, what you do then, I would just go back and plug it in how the original problem's laid out. So it's h of 2, which is 12. So I'm just like substituting these in. Minus, now this is tricky. So when we did g of 3, it ended up being -34. So if I substitute that back in, it's going to give me minus a negative. So just be careful with that because that's actually going to turn into an addition problem. And then plus 2, excuse me, times f of 4. F of 4 was 6. So I'm just plugging in what I got when I evaluated each one of those. And you could totally just type this on your calculator if you want to. I'm going to simplify this a little bit. This is going to be 12 plus 34 minus a negative, and then plus 12. And you just want to simplify it as much as possible. You just add those guys up. You should get 58 as your final answer there. Okay. Does anybody have any question? Just gonna do one more real quick with you guys. This one has a fraction to it. So I need f of 3. So using the same function up here, this would be just 3 plus 2. Just make sure you plug it into the correct function rule. That's 5. G of 5. G is in the middle. That's negative 10x minus 4. So if I want g of 5, I'm going to do negative 10 times 5 minus 4. Let's see, negative 50 minus 4, so negative 54. And then I need, let's see, h of 1. So just those are the three things I need to figure out the problem here. H is 3 times my x value plus 6, and I want my x value to be 1. So it'd be 3 plus 6, so that would be 9. So once I get that, then I just go back and replace or substitute each one of those into the original problem. Now, f of 3 was just 5, so I'm going to put that on the top. The bottom says g of 5, which was negative 54 plus h of 1 plus 9. So if you can, go ahead and simplify that. So on the bottom there, negative 54 plus 9, right? That's negative 45. And then if you can, which I also can here, I can reduce that fraction. Both of those are divisible by 5. So my final answer there should be negative 1/9, all simplified. And so as you do these problems, they're not bad to do. It's just kind of the notation and making sure you're plugging in correctly and substituting and then simplifying if you can. Now, when you guys get to the homework tonight, the last couple problems,